One important property of continuous time Fourier transform is linearity. What does it mean? It means if you have a signal and this signal consists of two signals and they are added together or subtracted, so the Fourier transform in this case will be equal to the Fourier transform of the first term plus the Fourier transform of the second term. Okay, we have an example here. We have a signal. It will be hard if you apply the integral form to find it, because you're going to divide it into many subintervals and start to do the integration. But if you can split this signal into two signals added together, that would be easy. When you look at it, it looks like you got two rectangular pulses added together. See? So let's just look at it in this way. If you have this signal and divide it into two signals, and there is one signal start from -2 up to +2, and the height is 1, and you have another signal, rectangular pulse also, but it's from -1 to 1, the height 1. So when you look at it, the one in the middle between -1 and 1, and also it's between -1 and 1 here, just let me mark it here, from -1 to 1, also you have height 1. So when you add, you get 1 plus 1 is equal 2. So you get this portion. When you're adding the whole signal to just the part inside from -1 to 1, height 1, you get 2. And between 1 and 2 in this signal is 0. Between -1 and -2 is 0. So when you are adding this 1 to 1, you get 1. And you add 0 between -1 and -2 to -1, -2 is equal 1, you get 1. So that's right. So you can say that xt, in this case, you can say that xt of t is equal to x1 of t plus x2 of t. Okay. Now we'll try to find the Fourier transform of the first one. We'll call it x1 of omega. It's a rectangular pulse, and that's the formula that you're going to use for rectangular pulse. We got it from the table. The width is equal tau. In this case, the width is equal 4. Between -2 and 2 is equal 4. So you substitute by tau equal 4. So you have 4 sinc omega, or 4 omega divided by 2 pi. And after simplifying, we'll have 4 sinc 2 omega over pi. So that's x1 of omega. Okay, what about the second one? Second one, it's very similar to the first one, except only the width here from -1 to 1. So tau is equal to, we'll substitute in the same formula here by tau equal to. So you have x2 of omega is equal to sinc 2 omega over 2 pi. And after simplified, we'll have 2 sinc, that's sinc omega over pi. So that will be the second signal, x2 of omega. And since x of t, we just prove it, equal x1 plus x2, so x of omega will be equal to x1 of omega plus x2 of omega. Then you add them. That's x1 of omega is equal 4 sinc 2 omega over pi plus 2 sinc omega over pi. And that will be the final answer. So it's really very useful using linearity, and we'll see more example in next videos.